Hey, good morning, everyone. Nice to see you back everybody's back, right? Yeah, that's good. Because I think when you are before the break, the problem is people want to take a break. After the break, people haven't come back. But that's good. Okay, we'll get started quickly. What I would want to focus on is dive a little bit deeper into the how of things. You heard Kevin and Grant talk about what we want to do, why we want to do. Let's go a little bit deeper. Half an hour is probably not good enough time, but we'll stay at a high level. We'll not go down. I'm not going to open an AI coding assistant to write code here. I'm not going to do that, so we'll stay high level. What is really important is that how do you enable that intelligence platform? How do you make sure that we lay the foundation on which we can build and continue to build as things will evolve? It's not something that we build once and it stays stagnant. The technology will keep evolving. In the past 3 years, I think we have seen that's the fastest growth in the technology area. But we also want to make sure that it's a seamless and a scalable ecosystem that we are creating on which we can continue to build and continue to optimize ourselves. So before we go down into how we are going to do it, what we are going to do it, I think it's important to understand what the reality is. The reality is that we currently have a landscape in which we have technologies which have spanned across 4 industry-leading companies. We know that we have been looking at optimization, LiDAR, geoprocessing, ERP integrations, IoT, all over the place across 4 distinct companies. Now, having this collaboration or consolidation of 4 companies gives challenges, but also gives opportunities because each of the pieces was built standalone, but each of the pieces was built to add the value. One of the key things that I've learned over my career in technology is the hardest thing is to build a solution for a business problem. Refactoring it, re-engineering it, integrating it, that's the easy part. So I think the hard part has been done. A few more pieces have to be done, but that's fine. But at least whatever we have now is a good solid foundation on what we can build in terms of the business enablement. So since each division has evolved independently, worked independently, so we have to figure out how do we make sure that whatever we do, however we progress, we're not disruptive to you. We want to make sure that we keep on moving you forward in the right direction the way it is valuable for you. So one of the important aspects is to look at your needs, what we are hearing as a feedback, and work backward from there and make sure our platform is designed and capable of meeting and exceeding your needs as we move forward. So what we have heard very clearly is a strong emphasis on stability, scalability, reliability, security. That's been extremely important, and that's where things have been a little bit shaky as well. But what we want to do is we want to move forward and take those as core ground principles that whatever we are doing, we want to make sure that we're always looking at those aspects with importance. We want to reduce the fragmentation from these individual systems as we move along and make sure we can interoperate smoothly. We can pass information back and forth. We can have a validation going on between systems all the time. We want to make sure that whatever we build it iteratively, we build it in a continuous manner so that we don't disrupt the environments that you have. We want to make sure that we want to keep on adding value as we move along and build on the foundation that we have built. So what's important for that vision is enabling that digital intelligent ecosystem. Now, if we know that data has been in silos, systems have been in silos, intelligence cannot be built on silos. Intelligence have to be built on something which is more unified, more collaborative, more integrated. So that's one of the vision that we are looking for, is to make sure that we integrate things together. We want to reframe the individual products that we have so far and orchestrate them, make sure that they work as gears which synchromesh with each other, which work together to give you the end-to-end flow for the forestry value chain. A strong emphasis on decision support, because that's precisely what makes your business successful. So make sure that we can collect the data from various systems, various technologies, bring it all together, and form that intelligence layer on which we want to build on. We want to make sure that the decision support system that we are building is the one which is not affected by, or which is not inhibited by, the fact that there are multiple technologies working together in place. So let's take a look at what that blueprint is and what are the key principles. So what I'll go back is to some basics in the industry. We all know that monoliths are not what we want, layered architecture is what we have been looking for, but why is that important? Why are we still talking about those layered architecture? Because I think that's a strong foundation which over the years this industry has learned and acknowledged that is the core that has made every strong platform grow when it's layered properly. So in terms of the layers, at the very top layer, we're talking about the experience layer. This is where the interactions are happening. Now, interactions are not just application front ends that we are building. Interactions are system-to-system interactions as well. Interactions are whether it is systems through web services in the past, or through for the various UIs or various devices, or as we go more agentic, how do systems talk to each other? That's what's going to be important. The middle part, the integration layer, is important because we all know that when we change things, that impacts everybody else who's integrating with the system. So an API-first, API-focused approach allows us to make sure that we are defining things which will give us a stable platform, which will allow us to make changes to the platform as we move forward without disrupting everything every time. We want to make sure that the data layer is well formed, because as I was mentioning, data in silos doesn't allow to be doing anything intelligent. So what's extremely important is to make sure that we have a strong data foundation where we can ingest the data, we can process the data, we can keep the data for a long time. We're talking about how the compliance is going to be important. And that compliance is not, we're not talking about 6 months, 12 months. We're talking about years that the government agencies will ask us to keep the data for. How do we make sure we ingest the raw data in various formats? We don't want to be restricted by, oh, we can only take the data in this format. Whatever that raw format is, we want to ingest that data and make sure we can hold it for you for your compliance needs going forward. But at the same time, use that data, blend it, and join it with all other data sources and build up the intelligence. We want to make sure that the infrastructure layer, which is pretty stable but still expanding, right? We have talked about whether the data will be real-time, non-real-time. I think what's important is to be realistic about, hey, we want a variably connected system, because we will have connectivity, but the connectivities will go down. They will be flaky. Sometimes they'll be slow, sometimes they'll be fast. How do we make sure that we use that infrastructure layer with a good understanding about what the realistic parts of that infrastructure layer is and how to build on top of that foundation? So let's go into some of the core architecture, and this is something that has been there for many, many years. This is one of the stable core of the architecture landscape, where we have a layered architecture talking about the front end and the business layer and the data layer. But things have changed recently. When we started adding the web services world and the cloud, like 15, 20 years back, it is when we started building web services, when we started making sure systems could interact with each other across open protocols. We started adding the cloud hosting. That opened up a new door where the scalability of the infrastructure flickers, that's fine. So scalability of the infrastructure increased tremendously. With a background of last 6 years in AWS, that's where I saw the value of the cloud, what it has given to all the customers, especially in terms of data. How can you store that data and not worry about the day I'll need that backup for compliance? Will that backup really work? I'll take a tape backup and put it in and, oh, that doesn't work that day. we can forget about those things because we know we have reliability built in the cloud we can leverage very easily. We also started with that scale of data, we started building data warehouses and more analytics environment where we could build the dashboards and reports at ease. But as we move forward, what we want to do is have a well-defined data strategy where the data is not just within your environment, but data is something that you may want to publish as a product, where you want to have a data exchange across various environments, whether it is within the company, outside the company, across the forestry industry, or with the governments as well. How do we make sure we define a forestry data exchange platform where we can reliably work? What's extremely important there is how do we define the governance principles? How do we make sure the data quality is right, how the permissions are set, how the business glossaries are very well defined so that everybody can easily consume them. But as we move along, what has changed in the last 3-4 years is the widespread use of semantic data, making sure that the data is not just SQL queries running the data, but it has a meaning, it has semantic, and there are systems which can understand that meaning. How do you search that data? How do you build those knowledge bases which eventually enable your agentic AI workflow so that you're going from hard-coded logic that we have been used to. So we implement an if then else statement all across our systems, and we have done it for, I don't know how many years, 30, 40, 50 years. Now that's breaking up because now we are saying, hey, we have agentic AI where the natural language systems are so robust now that we can write that requirement in a natural language, let the agentic AI make that decision on which system to invoke at what time, and how do you do that orchestration. So that's the great thing that we are working on right now. But all that has to be done responsibly. We want to make sure that we have a strong architecture best practices that we follow across everything that we do, whether it is security, whether it is reliability, whether it is observability in the system, whether it's cost optimization, because as we know that we can build systems and costs can easily go out of scale very quickly. How do you make sure that all the best practices are always followed across all the solutions that we build? So that combined together is the foundation of the intelligence platform that we're talking about. Now, one of the key principles I think that I would like to emphasize is the unified data strategy. Why is that important? Is to make sure that we have the ability to ingest any amount of data in any format and make sure we can keep it for long-term retention, we can process it, we can join it, we can combine it, we can collate it, and we can draw intelligence out of it. That's extremely, extremely important. How do you make it from raw to an analytics ready across multiple systems? How do you take data from your planning and planning part, operations part, and then observability? How do you combine them together and get the intelligence and feed it back into the system? Hey, this is what we planned. This is what we are observing. We join them together. Now we have the realistic view about what has really happened and how do we feed it back into systems. What you will see later in the afternoon is a quick demo about how we are building these things together. That's the first showcase that we want to show, how we are taking all the spectrum of the products that we have and unifying them with this common approach, how the data lake under the hood makes sure that everything can talk to each other and we can use that data in an intelligent manner. So again, how do we use this foundation to have an accurate decision-making environment? How do we make sure that this data can then bubble up as well, whether we go through our applications or whether we go the product path? Whichever way we go, we want to make sure that this data is readily available. Now, how we are going to use AI to enable all this work? So a brief background about my involvement with AI. Early 1990s, I was building neural networks in C++ manually, building it for self-guided missiles. So the reality from those days, how we were building what we call expert systems, what we are calling them agents, which is really expert system with a new name, whatever the name is. But that's my background on how to build them from the very ground up programmatically. Yes, the computing scale has changed tremendously, but the core principles are still the same, which we are going to move forward with. But we have to do in a responsible manner. We want to make sure that all our teams have proper policies that they can adhere to, proper training that they can leverage. Because what's happening is the large language model being created, they're data hungry. If we don't protect the data properly, and this enterprise data I'm talking about, we have to be really careful. We have to be really vigilant about how we use this data, how do we make sure the policies are there, the license agreements are there, and we don't let the data out, whether it is Remsoft data or our customers' data. Both of them are equally important, and everybody in Remsoft needs to understand those policies, needs to understand the basic principles on why those things are important. So human judgment, from my perspective, human judgment is important because large language models, generative AI, will hallucinate. Whenever you don't want it to hallucinate, that's the moment it will hallucinate. So human judgment, I think, is extremely important to keep in mind on how we move forward. Okay, agentic AI enablement. Now, this is something that we are building into every product that we have so that the two products can talk to each other and the products can talk to other products, other systems outside the ecosystem in a defined manner. Defined in the sense, defined with the agentic AI protocols. That's the kind of definition, but still relying on natural language. Why is that very important? Is because of that getting away from that hard coding model. So large language models, I mean LLMs people call it, but at the ground what they are is they have been trained on a vast amount of data so they can understand the semantics and reasoning of the knowledge. So in every LLM, there's a very strong reasoning model, and that reasoning model is what allows us to orchestrate and build things so that we are not hard coding. I think Kevin was mentioning that you can step back and let the agents do the work, right? But how do you define what the agent has to do? If you start writing code, we are again back in the same problem of writing hard-coded code. We are talking about here is in natural language, we are defining what the goal is, what are the various tools which are available, and how does the reasoning happen. Oh, I see this happening in this particular system. The observability data says this is the harvested volume. The planning data said something else, where the mill was given some other details. How can that orchestrator can do multiple steps and figure out who to notify when an event happens? So with the event-based architecture, with agentic AI built into all the systems, that's how we are going to enable all these interactions to happen more efficiently. Now, extremely important is factual grounding. We had, a few months back, we were working on using Woodstock environment, using Woodstock documentation to build an LLM, to build a roboting tool so that we could generate the model language. What we figured out was, since these LLMs are so data hungry, they had trained themselves on a past version of the data. So when we started asking questions about, hey, do you know this particular syntax? Yeah, I know this syntax. But what we have to understand is that data was frozen on the day the training of that LLM, that version of the LLM ended. So it was an old data, dated data. It was giving us incorrect results. So what's important is to make sure that we build systems in such a way that it is our enterprise data, our source of truth, which is always used for any AI work, any generative AI, agentic AI work. It has to rely on the source of truth. It has to rely on only our data. And that's where retrieval augmented generation becomes very important, where we build knowledge systems, where we build knowledge bases and make sure the agents can only talk to that particular system for authentic data, but reasoning model they have on their own. So combining them together is what creates the power. Now, what is also important is how do we migrate? How do we build the new systems? How we go from old systems to new systems? And I think this is where we are leaning heavily on adopting an iterative approach, not a big bang approach, because we want to make sure that we don't disrupt your environments. We don't disrupt our own stability for the sake of moving faster with technology. So this particular migration technology using iterative will make sure that we can build it iteratively, build it slowly, and we can continuously take the feedback from the customers or from the systems that we are deploying into production and keep on moving forward with a stable environment there. Building for stability, building for resilience, going back to what are the basic principles that we are using for building the intelligence platform, we want to make sure that we build observability into our systems. When something hiccups, we want to know first. Before you know it, our people, our support people, our systems, our automated observability agents have to know about it so that we can take corrective actions very quickly. We want to make sure that we put a strong emphasis on QA automation. Make sure that the products that are being rolled out, every build, every deployment that happens has a good quality. We want to make sure that the release management is a well-defined process so that everybody knows when a deployment is happening, what's including in that deployment, and make sure that a regression test mechanism is automated so that we can scale quickly and move fast with it. We want to make sure that when we say we want to have reliability, we are building actually metrics. So that's a mechanism for us to measure how we are doing the work and building it as a stable platform. So the key takeaways, I will say, is what it looks like in 2027 is that building of that unified ecosystem, building the foundation of the data lake, making sure we are enabling the decision support systems in an efficient and accurate manner. We are using AI in a responsible manner, which doesn't put us on a slippery slope ever. Make sure that it is our source of records, our knowledge sources, our source of truth, which is going to feed all these agentic AI workflows and systems. And make sure we are building a foundation which is not stagnant, a foundation which can keep on evolving, but it is still strong at the core so that we don't have to come and rebuild it anytime going forward. So with that, I think I'd like to close here and make sure that this is not the end, but this is the beginning of our interactions on how the forestry intelligence platform is going to morph in future. Thank you.